functions and understanding them and getting used to the function notation, our next logical step is to talk about proportional relationships and how they deal with a function. So I want you to look really close at this graph. This graph is considered proportional because it starts at 0 and has a constant rate of change, up 2 over 1, up 2 over 1. Did you see those little steps? Up 2 over 1, up 2 over 1. As long as it starts at 0 and has a regular or a constant rate of change, it's considered to be proportional. So let's kind of see it. Keep that in mind as we go forward. All right, so a proportional relationship is proportional when the ratio of y over x is constant, the value of the ratio of two proportional quantities. It is represented by the equation y equals, or k equals k over y, where y represents the dependent variable in a table or graph, and x represents the independent variable in a table or graph. So you can find or calculate k using this idea, and then write it in the equation y equals kx. And that k is the same thing that we've been using all along, which we called slope, but it's found in a little different way this time. So here's a couple of examples you might see on ALEKS. First of all, do we have y equals something times x? Yes, so this is proportional. And the number in front of x, which is that k that we're just looking at, is 8, so k would be 8 in this case. On this next problem, however, we've got y equals 7x minus 1/2. The fact that we have a minus 1/2 on the end here means that this is not a proportional relationship. Remember when we looked a little while ago at the graph? A graph has to start at 0, 0, whereas this one would start at negative 1/2, so it doesn't follow the definition of proportionality. Okay, let's try another one. Well, this next one already has a number separate from the negative 476, or there's k and this is some other number, so this is not proportional. It would be like the y-intercept of 8. The part B of this one, however, is proportional, and the constant of proportionality is the number in front of x, which is 2. Okay, so a couple more little definitions. The rate of change describes how one quantity changes in relation to the other quantity. In a proportional relationship, the rate of change is equal to the constant of proportionality. So let's see how this works. So remember we said to find the constant of proportionality, we take the y value and divide it by the x value. So 6 over 1. Let's do it for each of these values. 12 over 2. 18 over 3. And 24 over 4. What does it equal in each case when I do this division? Well, the first one would be 6. 12 divided by 2 is 6. 18 divided by 3, 6. 24 divided by 4, 6. Oh, so our constant of proportionality is just 6 in this case. All right, let's try this one. So y over x, 4 over 8, 5 over 10, 6 over 12, and 7 over 14. So if you notice that you got one number over the other, and in every case they all simplify to be 1/2. So all the way down, those fractions simplify to be 1/2. So our constant of proportionality is 1/2. All right, so let's take a look at this one. We've got our, in this case, x is on top and the y is on the bottom. So if I come down here to the bottom where I got a little extra room, I'm going to put 8 over 1 and 18 over 2, 30 over 3. So when I divide the first one, I just get 8. When I divide the second one, I get 9. And when I divide the third one, I get 10. So these ratios or these proportions are not constant. They're changing. So this is not proportional. All right, let's take a look at this next one then. Get rid of some of that ink to get a little extra room here. All right, so we're going to do y over x, so 27 over 3. That equals 9. Then we're going to do 45 over 5, 45 over 5, and that also equals 9. Then I'm going to do 63 over 7, and 63 divided by 7 is also 9. And then the last, I'm going to do 90 divided by 9. Well, that equals 10. So we were looking really good until we got to the last step. And it doesn't work on that last step, so it's not proportional. So you got to check out all the steps. Okay, a couple more. Let's see. 16 divided, so we can kind of do it a little quicker. 16 divided by 4 is 4. 30 divided by 6, 5. 48 divided by 8 is 6. So just from those three divisions, y divided by x, we get different numbers. So this is not proportional. Okay. All right, how about this one? We've got 12 over 32. 12 over 32. Let's do one more. 18 over 48. So if I simplify these fractions, 12 over 32 is going to simplify to be, well, if we divide each of them by 4, that would give us 3. That would give us 3/8 on the first one. If I divided each of those by 4. If I divide these by 4, that's not going to go. So if I divide by 3, I would get 6 over 48 divided by 3. This is when you need to have your calculator handy, huh? 18. So that would go into 6 times. So it would be 6 over 16. Oh, I'm noticing if I divide each of those by 2, I missed a number. Divide each of those by 2, we'd get 3/8 as well. So this is proportional, isn't it? And the y is 3/8 times x. And that's how we got that 3/8 was doing y over x. Okay, so a couple more little definitions. The line, when we're doing a graph on, like we said at the very beginning, the line of a proportional graph always goes through 0, 0. The rate of change will be equal to the constant of proportionality k. And the equation of the line will look like that. Y equals something times x. And it could be a positive or a negative number. All right, so let's see how this works then. We want to find k. So instead of doing up and over like we did with slope, let's just look at our first one. We've got an x value of 1 and a y value of 10. So my constant of proportionality in that case would just be 10. And it's going straight up or going on a slant, but it has a constant slope. So I don't need to do any of these other divisions because I can already see that it goes up at that rate. So that means my equation will look like this. Y equals 10x. So, and I can look right here at this table. The first one would be 0, 0, right? So it has to start at 0. Then we have 1, 10, 2, 20, and 3, 30. So those are some pretty good numbers, huh? So what does the point 1, 10 represent in the relationship? So we all go over 1 and up 10. That means that it's $10 $10 per ticket. That's what that means. So $10 per ticket. Pretty cool. Okay, let's go on to the next one. We've got another one. This time the graph is connected, and so it's considered a continuous graph, but we still use the same method to solve it. So first of all, we've got over 1 hour up 3 miles walked. For every one, we got 3 miles, 3 walked. 2 and 6. 3 and 9. 4 and 12. So if we do y divided by x, in each case, 3 divided by 1, 6 divided by 2, or 12 divided by 4 for that matter, they all equal 3. That's our constant of proportionality. So our equation would be y equals 3x. Now what does the point 1, 3 represent? That for every hour walked, she goes 3 miles. So, or he. So what we're saying is that we're walking at 3 miles per hour. That's how fast we're walking. So if you can keep that up, it's going to take a little more than 3 hours. It'll take you 3 hours and 20 minutes to go 10 miles. So not bad, right? Okay, for each graph below, show a relationship between, or each graph does show a relationship between x and y. For each graph, determine whether x and y are proportional. If x and y are proportional, fill in the blank with the number. Okay, so this starts at the origin and goes up at a constant rate, so this is proportional. And I notice that from here to, well, y over x, in this case, when we had to go up to 2 and to get to this dot after we went over 1. So our constant of proportionality is 2 times x. Okay, on our next one, it starts at 4. It doesn't start at the origin like we told you it needed to. So because it starts at 4, this is not considered to be proportional. All right, for each of the graphs, show us the relationship between x and y. For each graph, determine whether x and y are proportional. If x and y are proportional, fill in the blank with a number in simplest form. Okay, so this one does not start at 0, so that means it's not proportional. In this one, it doesn't start at 0, 0, so it's not proportional. And at this one, it is proportional. So we're going to come up to our first known point, non-zero known point. We notice that our x value is 4, our y value is 5. So y over x would be 5 over 4. So our constant of proportionality is 5/4, so our equation will be y equals 5/4 x. Very nice. So our assignment is number 45, proportional relationships. Very similar to some of the things we've been doing, but a few differences. So keep your notes close by so you can refer to them.